Hello, dear students. As you can remember, my name is Tatiana Vladimirovna Peterimova, and today we are going to talk about energy. In this lesson, you will know what exactly energy means. Also, you will know and you will see some different examples of energy. And at the end of this lesson, I will tell you what kind of homework you should do about this lesson. No, let's go. First of all, guys, what is energy? Energy, this is the ability to do work. Work is done when a force causes an object to move in direction of the force. Works are a transfer of energy. Energy and work are expressed in units of joules. Here in this slide, you also can see the example of energy and work. The tennis player does work and transfers energy to the racket. With this energy, the racket can then do on the ball. Also, in this page, you can see the example of kinetic energy. Kinetic energy is the energy of motion. All moving objects are kinetic energy. Also, as we can see, kinetic energy depends on mass and speed. If you know an object's mass like m and its speed like v, you can calculate the object's kinetic energy with the following equation. Let's talk about potential energy. Potential energy is the energy an object has because of its position. Also here you can see an example of potential energy with balloon and also with the Eiffel Tower. Gravitational potential energy. This is the amount of gravitational potential energy that an object has depends on its weight and also its height. Let's talk about mechanical energy. Mechanical energy is the total energy of motion and position of an object. Both kinetic energy and potential energy are kinds of mechanical energy. The equation to find mechanical energy is the following. Exactly, this is our formula, how we can count this mechanical energy. For this, you need mechanical energy. It's equal potential energy plus kinetic energy. And also here, from the left side, you can see two examples of this kind of energy. Go further. Mechanical energy of an object remains the same unless it transfers some energy to another object. But even if the mechanical energy of an object stays in the same, the potential energy of kinetic energy can increase or decrease. Let's talk about other forms of energy. First of all, this is our thermal energy. Exactly, this is all of the kinetic energy due to random motion of the particles that make up an object. All matter is made up of particles that are always in random motion. So, all matter has thermal energy. Thermal energy increases as temperature increases and increases as the number of particles also increases. In this page, you also can see some examples of thermal energy in water. In the first picture, you can see how the particles in an ice cube vibrate in fixed position and do not have a lot of kinetic energy. In the middle, in the second picture, you can see the example of how the particles of water in lake can move more freely and have more kinetic energy than water particles in ice do. And in our last picture, you can see how the particles of water in steam move rapidly, so they have more energy than the particles in liquid water do. Let's talk about other forms of energy. Chemical energy is the energy of a chemical compound that changes as its atoms are rearranged. Chemical energy is a form of potential energy because it depends on the position and arrangement of the atoms in the compound. The energy in food is chemical energy too. Don't forget about this, please, dear students. Electrical energy is the energy of moving electrons. Electrical energy can be thought of as potential energy that is used when you plug in an electrical appliance and use it. Sound energy is caused by an object's vibration. The object's vibration transmits the kinetic energy to the air particles, which also vibrate. This vibration transmits sound energy. Light energy is produced by the vibration of electrical charged particles. Nuclear energy is energy that comes from changes in the nucleus of an atom. Nuclear energy can be produced when nuclei are joined in fusion reaction or when a nucleus is split apart in a fission reaction. Also, we have solar energy. This is exactly radiant light and heat from the sun. It is renewable energy and it is used as solar power to provide electrical generation. Geothermal energy originates from the original formation of the planet, from radioactive decay of minerals, and from solar energy absorbed at the surface. It is power extracted from heat stored in the earth. Guys, right now exactly you have know about some different forms of energy. After this lecture, you will have some tasks. Exactly, this is our reading part, our speaking part, and the last task where you will have some kind of questions. Please answer for all these tasks to know how other forms of energy works. Thanks for your attention.